Introduction.
Mom, what are you doing?
I'm repacking the cutlery that I had taken out for yesterday's party.
Mom, if you teach me, I can help you with the repacking.
Thanks, Shikha. Place all the spoons of the same size and shape together in one box.
Wow, that's a wonderful way of putting the concept of congruence to practical use.
In this lesson, you will learn about congruence of triangles.
Objectives. At the end of this lesson, you'll be able to define congruence, determine congruence of lines and angles, determine congruence of triangles with the help of SSS, SAS, and ASA criteria. Determine congruence of right-angled triangles with the help of RHS criterion. Congruence. Look at these objects. What strikes you about them? Yes, you are right. They are identical. Let us look at some more identical objects. We will now perform an activity with these objects. First, we draw their outlines and then remove the objects. Next, we slide the outlines of each pair of identical objects one over the other. What do we observe? The outline at the bottom is invisible. It merges with the outline on the top exactly. Two objects identical in their shapes and sizes are said to be congruent to each other. Exact correspondence of two objects in shape and size is called congruence. This is the symbol of congruence. Here are two line segments, PQ and ST. We will check if they are congruent. The line segments are congruent as their lengths are the same. It is also true that if two line segments are congruent, then they are equal in length. Here are two angles, angle AOB and angle PQR. Let us find out if they are congruent. The angles are congruent as their measures are the same. It is also true that if two angles are congruent, then they are equal in measure. Congruence of triangles. Triangles are said to be congruent if they are identical to one another. Sides, angles, and vertices are matched to test triangles for congruence. Side LM is equal to side XY. Side MN is equal to side YZ. Side LN is equal to side XZ. Angle LMN is equal to angle XYZ. Angle MNL is equal to angle YZX. Angle NLM is equal to angle ZXY. Vertex L corresponds to vertex X. Vertex M corresponds to vertex Y. Vertex N corresponds to vertex Z. Therefore, triangle LMN is congruent to triangle XYZ. Congruence in triangles is proved with the help of SSS criterion of congruence, SAS criterion of congruence, ASA criterion of congruence, RHS criterion of congruence. SSS criterion of congruence. According to the SSS criterion of congruence, two triangles are said to be congruent to each other if all the three sides of one are equal to the corresponding sides of the other. It is so because given the three sides, a unique triangle can be drawn. In triangles LMN and XYZ, side LM is equal to side XZ, side MN is equal to side YZ, side LN is equal to side XY. Vertex L corresponds to vertex X, vertex M corresponds to vertex Z, vertex N corresponds to vertex Y. Therefore, triangle LMN is congruent to triangle XZY. SAS criterion of congruence. According to the SAS criterion of congruence, two triangles are said to be congruent to each other if two sides and the included angle of one are equal to the corresponding sides and included angle of the other. It is so because given two sides and the included angle, a unique triangle can be drawn. In triangles LMN and XYZ, side LN is equal to side XY. Angle LNM is equal to angle XYZ. Side MN is equal to side YZ. Vertex L corresponds to vertex X. Vertex M corresponds to vertex Z. Vertex N corresponds to vertex Y. Therefore, triangle LNM is congruent to triangle XYZ. ASA criterion of congruence. According to the ASA criterion of congruence, two triangles are said to be congruent to each other if two angles and the included side of one are equal to the corresponding angles and included side of the other. It is so because given two angles and the included side, a unique triangle can be drawn. In triangles LMN and XYZ, angle LNM is equal to angle XYZ. Side MN is equal to side YZ. Angle LMN is equal to angle XZY. Vertex L corresponds to vertex X. Vertex M corresponds to vertex Z. Vertex N corresponds to vertex Y. Therefore, triangle LNM is congruent to triangle XYZ. RHS criterion of congruence. According to the RHS criterion of congruence, two right-angled triangles are said to be congruent to each other if one leg and hypotenuse of one are equal to the corresponding leg and hypotenuse of the other. It is so because given one leg and the hypotenuse, a unique right-angled triangle can be drawn. In right-angled triangles LMN and XYZ, angle LMN is equal to angle XZY. Side MN is equal to side YZ. Hypotenuse LN is equal to hypotenuse XY. Vertex L corresponds to vertex X. Vertex M corresponds to vertex Z. Vertex N corresponds to vertex Y. Therefore, triangle LMN is congruent to triangle XZY. Self-assessment. Match the items of columns A and B and identify the missing elements in the congruent triangles. Self-assessment. Drag and drop the options at the appropriate places on the triangles. Summary. Let us summarize what we have learned. Congruence is exact correspondence of one object with another. Two line segments are said to be congruent if their lengths match. Two angles are said to be congruent if their measures match. Two triangles are said to be congruent to each other according to the SS criterion if all the three corresponding sides match. Two triangles are said to be congruent to each other according to the SAS criterion if two corresponding sides and the included angle match. Two triangles are said to be congruent to each other according to the ASA criterion if two corresponding angles and the included side match. Two right-angled triangles are said to be congruent to each other according to the RHS criterion if the lengths of the corresponding legs and hypotenuse match.